Let's look at Chief Mate's MCA Stability Examination, July 2015, question 1. It says, a box-shaped vessel floating on even keel in dock water of relative density 1.014 has the following particulars. Length 124 meters, breadth 20 meters, draft 7.8 meters, Mctc saltwater 300.1. There is an empty watertight forward and bottom compartment, length 10 meters, height 6.5 meters, extending the full width of the vessel. Calculate the draft forward and aft if this compartment is bilged. We'll first make the drawing for this vessel. So this is the box-shaped vessel. The length of the vessel is 124 meters. This is the breadth of the vessel, which is 20 meters. This is the initial water line. So the initial draft is this, which is 7.8 meters. The length of the flooded compartment, since it was a forward end compartment, the length of the compartment is 10 meters. The breadth of the compartment, since it extends up to the full breadth of the vessel, is 20 meters. This compartment has a watertight flat, so the height of the flooded compartment is 6.5 meters. This is the compartment which has been flooded, which has been filled with the color of blue. While we'll solve any of the bulging questions with the lost buoyancy method, we make certain assumptions. So assumption number 1 is kg constant. Assumption number 2, displacement constant. Assumption number 3, underwater volume constant. So we'll write buoyancy lost is equals to buoyancy gain. So this part is the lost buoyancy, and volume equal to this part has to be redistributed here. So this is the gain buoyancy. So the lost buoyancy will always be equals to the gain buoyancy. So buoyancy lost is length of this compartment, the breadth of this compartment, and height of this compartment. So we have written length as 10 meters, breadth as 20 meters, height as 6.5 meters. Now buoyancy gain is this part. So we have written it as capital L, which is the length of the vessel, which is 124 meters. Capital B, which is the breadth of the vessel, which is 20 meters, times the sinkage. So this is the length, which is 124 meters, breadth would be 20 meters, and this part is the sinkage. While we solve for sinkage, we will get the final answer of sinkage as 0.524 meters. We'll now calculate the bilged draft. So bilged draft is equals to initial draft plus sinkage. Our initial draft was 7.8 meters, which was given in the question. The sinkage was 0.524 meters, which has been obtained from here. So our bilged draft becomes 8.324 meters. If we look at the drawing to understand this, this was our initial water line. This was our initial draft. This was our sinkage. So this entire value is our bilged draft. After calculating the bilged draft, we'll make the table for the LCB, which has the following columns in it. Number 1, description. Number 2, volume in meter cube. Number 3, LCB in meters. Number 4, longitudinal moments in meter to the power of 4. So we'll make the first entry, which is the bilged vessel. If we assume the bilged vessel to be floating freely in this water and it didn't have any bilged compartment, so the length of the vessel would be 124 meters. The breadth of the vessel would be 20 meters. These two parameters were already given in the question. what has changed is her bilge draft, which was now 8.324 meters, which has been calculated from here. Since this vessel was to be at even keel, which was given in the question, so LCB has to lie exactly at the center. So we have written half of 124 as 62 meters. And we get the associated longitudinal moments, which is by multiplying these two numbers. Some people think that why it is half of the total length. The reason behind is, if this was our box shaped vessel and this was our aft perpendicular, so there was a longitudinal center of gravity initial, which was somewhere here, and the vessel was supposed to be at the even keel. So there would have been no lever between B and G. That means B and G would have been in the straight vertical line, in the same vertical line. So because of this reason, in a box-shaped vessel, especially in a box-shaped vessel, the LCB would be lying exactly at the midship. If the vessel would have been trimmed, then the LCB would have not been exactly at the midship. Then we make the second entry, which is the buoyancy lost. So buoyancy lost, if you look at the drawing again, this was the length of the compartment, which was 10 meters. This was the breadth of the compartment, which was 20 meters. And this was the height of the compartment, which was 6.5 meters. The same has been made here, which is 10 meters multiplied by 20 meters multiplied by 6.5 meters. If this bilged compartment would have been floating freely in salt water, then her LCB would have been 119 meters. And the longitudinal moments would have been obtained by multiplying this number times this number. Now, how this 119 meters came into place? As we know that this was our aft perpendicular, from here till this point is 114 meters. If it would have been floating freely, then the point of B, which is point of buoyancy, would be lying exactly at the center, geometric center. So from here till point B would have been half of 10 meters, which is 5 meters. So the total distance from the aft perpendicular till point of B would be 114 plus 5, which will give us 119 meters. The final answer to sum up the table is for the total. So the total volume is 124 multiplied by 20 multiplied by 7.8. You can write it in this way, or you can straight away product this number and product this number. And once you have got the product here, you will take off this number from the product which you had obtained here. This value has come up from the fact that in the very beginning of the question, we had assumed that the underwater volume remains constant. So the underwater volume is basically the length, which is 124 meters, the breadth, which is 20 meters, and the draft, which is 7.8 meters. So the same answer has come up here. When we take off this number from this, we will get the total longitudinal moments. Now, in order to calculate LCB final, we will take this longitudinal moments divided by this total value. So total longitudinal moments is this value, which has come from here, and total volume, which is this value, is equals to 19344. When we solve this thing, we'll get the final LCB as 58.168 meters. We'll now calculate the change in LCB initial and LCB final. So our LCB initial was 62 meters, LCB final was 58.168 meters. So the shift in center of buoyancy is 3.832 meters. The next step is to calculate the Mctc dock water. So Mctc dock water is given by Mctc salt water, which was given in the question, divided by the relative density of salt water, which is 1.025, multiplied by relative density of dock water in which the vessel is floating. When we put in the values, the Mctc salt water given in question was 300.1 divided by 1.025 multiplied by 1.014, which has given us the answer of 296.9. We'll now calculate the trim because we have been asked to calculate the forward and aft draft. So trim is equals to trimming moments divided by Mctc dock water. So trim is equals to BB dash multiplied by displacement divided by the Mctc dock water. Now, the formula which we are used to for calculating trim is actually trim is equals to weight times the displacement, trim is equals to the distance times the displacement over Mctc. Now, this is the same formula what we had been using. The other formula which we use for calculating trim is actually weight times the difference of Lcb and Lcg over Mctc. The formula which we are using here is the simplified formula of this part. Now, how it is simplified, we will need to look at the drawing. This was the aft perpendicular of the vessel, and in the question it was given that the vessel was initially at the even keel. That means the point of center of buoyancy and point of center of gravity lies exactly in the same vertical line. Now, since the vessel has been bilged forward, its center of buoyancy has shifted towards the aft perpendicular as shown in the question. So center of buoyancy has shifted somewhere here, where I will say it as B dash. Now, the lever which is acting right now is across center of buoyancy in the bilge condition, which will be acting upward, and the force through center of gravity which is going to act downwards. So this lever is actually going to make the vessel trimmed by head. Now, the lever which is formed right now is B dash B, or in other words, we can straight away say the distance between the Lcg and the new Lcb, because both this value B dash B and the difference between Lcg and the final Lcb are equal. So we can use any of these two values. So that is the reason we are using this part in the formula. So trim is equals to 3.832 meters, which had been obtained before, which is this value, times the displacement, which is the length of the vessel 124, multiplied by the breadth of the vessel, which is 20 meters, multiplied by the initial draft, which is 7.8 meters, multiplied by the density in which she is floating, which is 1.014, divided by the Mctc dock water, which is 296.9, which has been obtained from here. Since we were using Mctc in the formula, so the trim which we will get will be in centimeters. So we have got our answer as 253.2 centimeters or 2.532 meters. Now we can say that LCF is equals to LBP divided by 2, because there is no change in water plane area, and also because it's a box shaped vessel. Both these two things together help us to understand that LCF lies exactly at the half of length between perpendiculars. So LCF is equals to 124 divided by 2, which is 62 meters. Now, in order to understand why LCF is equals to LBP divided by 2, we need to look at the drawing again. This was the initial water line, and the red one is the final water line. If you look at the initial water line, the length of the vessel was still 124 meters and breadth of the vessel was 20 meters. So we had some water plane area, which in case was 124 multiplied by 20. Now when we look at the bilged water line, this was our bilged length, which was again 124, and this was our bilged breadth, which was again 20. So the bilged water line was again 124 multiplied by 20. With this, we can clearly see that the water plane area hasn't changed. And also because of the fact that this is a box ship vessel, that's why the LCF lies exactly at the midship. Now we can say that trim forward is equal to trim aft is equal to total trim divided by 2 because LCF is at midship. So trim forward is equal to trim aft, which is equal to 2.532 divided by 2, which gives us an answer of 1.266 meters. Now we'll be calculating the forward draft in bilged condition. So forward draft is equals to the bilged draft plus trim forward. Now we know that the vessel is going to go down by head because if we look at the box ship vessel's drawing, and this is our aft perpendicular, where the vessel had its center of gravity and center of buoyancy initial in the same vertical line. Now due to flooding of the forward end compartment, the center of buoyancy has changed, which has moved towards the aft perpendicular, which is, I'm making it as B dash. So the new force in the bilge condition which are acting on the vessel is through B dash, which is vertically upwards, and through G, which is acting downwards. Now these two forces together is going to make the vessel go down by head. That's why we are adding trim forward for calculating the forward draft. So bilge draft, which is 8.324 meters, plus trim forward, which is 1.266 meters, which has given us the final answer for forward draft in bilged condition as 9.590 meters. Aft draft in bilged condition is bilged draft minus the trim aft. It's again because of the same reason that vessel is going to go down by head. Aft draft bilged is equals to 8.324 minus 1.266 meters, which has given us aft draft in bilged condition equals to 7.058 meters. So our final answer for the question is the forward draft in bilged condition is 9.590 meters and the aft draft in bilged condition is 7.058 meters.